Hello and welcome. This is the third video about networking. So in the previous video, I worked on the networking code for C#, and I decided to bring that C# code into Unity since Unity is also using C#, and I have created a package using that code. I have placed it in a repository, which I'm going to put the link in the description of the video. You can download it in the releases and you can get the last version. So basically when you import it into your Unity inside the packages developers hub, real-time networking, that is a name I chose for the package. So in the scripts, we have the client, packet and server script, just like the previous video. And I've also added a thread dispatcher because since some of the events of TCP and UDP happens in background threads, I've created a thread dispatcher to bring that inside the main thread. I've also worked on the code and improved it, and both server and client have different events. Let's take a look. I've created an empty script. So let's go to the start function. First, let's use the namespace, real-time networking. And for example, let's say server dot, we have three events: on client connected, on client disconnected, on packet received. Obviously, the name of these three events clearly explaining themselves that what they do. If we add a listener for each one of them, like this, and finally server dot on packet received. So I wanted to give you full access using this package. Because of that, you can create multiple instances of servers using this package. For example, when you want to create a server, you can simply say server that create new server. So let's go to this function and see what it does. It simply is going to create a game object and add the server component to it and then call server initialize. It's not going to do anything important. So it's basically going to create an instance, and then when we call server that start server, it is going to take a port and the maximum connections that are allowed to connect to this. So any port number you want to choose, any player number you want to choose, and that's it. It is going to create that server for you. And every time a new client connects to that server, it is going to call this function, passing the server and also the ID of that client. It is basically going to assign an ID to each client. And every time you want to send a packet to a specific client, you can just say server send packet, and it's going to take a client ID from you. So that is the ID of the client. It is going to take a packet, and it is going to take the protocol, which is either TCP or UDP. So that's how you can work with the server. We also have the client class, which also has three events. So on a connection attempt, on a disconnected, on packet received. So on packet received is obvious. On disconnected is also obvious. So whenever you get disconnected from a server that you've previously connected to it, this event is going to be called. But this is on a connection attempt. So basically when you try to connect to the server, either you're going to be successful or it's going to fail. So this is for that. Let's implement the listeners. So on connection attempt, on disconnected, on packet received. So just like the server, whenever you want to create an instance of a client, you say client dot create new client. So if we go to this function, let's take a look. It is also going to create an empty game object, attaches the client class to it, and then calls the initialize for it. So client dot connect to server, it is going to take an IP address and a port number. So simply like that. So when you call this, and by the way, that is the IP of your local device. Whenever you want to connect to your local device, that is the IP for it. So if you call client connect to server, this event is going to be called on connection attempt. So it's going to pass the client. So that's the client. It is going to pass a boolean, giving you either it is successfully connected or it is failed. If it is false, then this error string is going to have a value, which is the error why the connection did not happen. So the difference is, let's bring back the server example. Create first and then start it. So if we take a look at the start server class here, it is going to return a boolean. So we could get that boolean to see whether the server was actually started or not. So this is mostly always true unless you already have a server on that port, or if something is wrong with your network. But most of the time it's going to be true. And when you call a start server, it's actually going to start the server. But for the client, when you call connect to server, it might fail because a server might not be even starting on that port. So that's why we have on connection attempt on the client. Basically, that is 3 events for the server, 3 events for the client, how you can start a server or connect a client. It's as simple as this. And to send packet from server to client or from the client to server, let's, for example, create a method here, send test, and let's say you already have a server started. So when you want to send data from the server to a specific client, you can easily say using packet, it's going to be a new packet. So now we can write any type of data in this packet. For example, I want to write an integer as my packet ID. I can write a float. I can write a string. I can even write a vector 3. And once I've written all the data into the packet, then I can say I want to send the packet using this server. So I'm going to say test server dot send packet. So the first input is the ID of the client that we want to send the packet to it. The second one is the packet itself. And the third one is either UDP or TCP. And just like that, you can send a packet. And on the other side, when you receive this packet here, for example, on the client on packet received, when you read the data from the packet, you need to read it in this exact order. I recommend always write an integer first as the ID of your packet, and then the first thing you do, you're gonna say packet read int, and then using that ID, you know that if it is 0, you should expect a float and a string and a vector 3, and you can read them in that exact order. So for example, like that. So that's the float. We also read the string, and we can also read the vector 3. And of course, we need to make sure our ID is actually 0. So just like that, we could send a packet and receive it on the other side. And it's the same way for the client. When you want to send a packet from the client to the server, you can do exactly the same thing. And instead of a server send packet, you can say client send packet. And since client only can send to the server, you don't need to pass an client ID. So that's it for sending data. And you can create as many instances of any servers on different ports. You can have multiple servers on different ports, or as many clients as you want. So you can have multiple servers on the same Unity instance. So if we take a look at the demo project here, by the way, this is the demo script. Here it is. You can check out this script to learn how to start a server, connect a client, and here how to send a packet. It's easy. So let's go to the demo scene here, and I've already created a build for it. Let's run the build and maybe run another instance of the build. So if I play this now, let's say I want to start a server on port 6060 start. That's it. This has a server running on that port. And if I want to connect this instance to that server. IP would be 127.0.0.1 for our local device. If you have this instance running on another device on a server somewhere else, then you enter the IP address for that server. But since all of our instances are running on the same computer, on the same device, that is always the IP address. So that is the port. Connect to it. So as you can see, client connected. I can send a message to it, and here we can also connect this one as a client. That's it. So that's our client. That's it. So this is how you can work with this package. You can also, let's say we want another instance of the server on that port, just like that. You can do that. And basically I did not go through the code because I've already did that in the previous video. I know that I've added some stuff and I've improved the code, but the core concept is still the same. So I didn't want to waste your time writing a bunch of code. You can go ahead and check it out yourself. It's just 3 simple scripts, and actually 4 scripts. I've added an extra script, and it's not very complicated. And by the way, this is not a complete networking solution for multiplayer games. This is just a simple TCP UDP connection to send and receive data. So the famous packages like Mirror or Netcode, they're actually using the exactly same method to send and receive data, but they have built extra options on that foundation to synchronize transforms, synchronize animations, variables, client predictions, and so many other options that are just going to work out of the box. And this package is just a foundation that you could build your own personal networking system on it. So I hope this was useful for you. Please consider liking the video and subscribing to the channel. Thank you for watching.